Good morning. This lesson is for my Honors Integrated 1 class. This is section 3.1 in our book. But before I get started, I want to say I hope everyone's doing okay out there. So let's go ahead and jump into our goals for this lesson. We have 3 goals today. Our first goal is going to be to interpret graphs. Our second goal is to discuss the difference between continuous and discrete. And our third goal is to start to talk about domain and range. All right, so let's jump into our first goal, interpreting graphs. So here I have a graph that represents a situation. Now, I did not say what this horizontal situation represents, and I did not say what the vertical situation represents. But what I want to do is I want to talk about the behavior. There's 4 different behaviors in this graph. And so what I'm going to do is I'm going to move my fingers along the x-axis and move my fingers along the y-axis to show you what's happening here, okay? So we start the graph here at the origin, and we move at a steady rate to here, okay? So my x value is lined up, hopefully, to that, and my y value is lined up, hopefully, to that. So again, we move in a nice, steady state. Now, notice that the second segment is actually steeper than the first. So I'm going to move my fingers along. Let's see if I can do this. You saw how my hand went faster on the second one. Let me show that again. Okay? So what's happening is the change in y is happening faster on the second segment of the graph. Now, when I get to the third segment of the graph, my finger, which represents the height of the graph, it does not change. I'll get to there. And then as I get to my 4th segment of the graph, my y value starts to come back down. All right, so a couple observations. X is always moving away. Y can go up, it can speed up, it can stay, and it can drop back down. So let's see if I can do this. Okay, so that is representing something that's happening in the graph. I'm not going to give a specific idea for what the horizontal concept is and what the vertical concept is, but I wanted you to see how the y value was behaving differently based on where the x value was. Okay, so I want to check off that first goal here, and I'm really being vague with this on purpose. Okay, I'm being very vague on purpose. All right, our second goal is to talk about continuous graphs versus discrete. Here I have an example of a continuous graph. My U's are not very good. I need to get better at writing U's. And here's a picture of my discrete graph. Really, it's an easy description to, or easy distinction to make. Continuous graph, so there's no gapping, it's just a solid, continuous curve or line. There's no breaks. Discrete means that there's individual points. So in this assignment, you might be asked to determine, is this situation continuous or discrete? I like to ask myself, does half make sense, or does 1.5 make sense? Meaning, if we're talking about a situation where you're at work for an hour and a half, does that make sense? Then you would say, yes, this situation is continuous because there's no gapping. An hour and a half makes sense. If we're in a situation where you're buying t-shirts, does it make sense to buy 1.5 t-shirts? No. So we would consider that a discrete situation. So continuous partial values work. Discrete partial values do not work, do not make sense. Okay, I can only imagine the salesperson at a shop when you go in and say, I'd like to buy half of the hat. Makes no sense at all. Okay, so that's the basic understanding of the difference between continuous and discrete. Continuous works for partial values, discrete works for only whole values. Whole value, x values, because price can be partial values, right? Like $1.50. But as long as you buy 1 or 2 or 3 at $1.50, 3, 4.50, that should be okay. All right, so now I'm going to talk about domain and range. And domain and range is kind of one of these things that it takes a little time to get the hang of. But this is going to be a lesson that I drag along for a while because it is an important lesson. All right, so domain, these are the X values, and it's literally a horizontal description, and we call these the independent values. Range are the Y values. It's a vertical description, and it's the dependent values. Sorry about that. These are the dependent values. So back to our graph, let me talk about the difference between independent and dependent. Depending on where my X value was, that determined how my Y value was behaving, right? So the X value is controlling the Y value. That's what independent and dependent means. The Y value depends on the X value. Now, when we're talking about the horizontal description, what we're doing is we're just talking about how wide the graph is. Now, you have to pay attention to what type of graph we're dealing with. Am I talking about the domain of a continuous graph, or am I talking about the domain of a discrete graph? Now, if we are talking about the domain of a continuous graph, the domain has to be an inequality, right? So let's just say that this value here was A, and this value here is B. We would say that the domain, or the horizontal description of this graph, we would say domain, and this is why we talked about inequalities as compound inequalities, is you're going to tell me the shading is technically between A and B. So the domain would be between the values of A, and we're going to use X because X is my horizontal value. So the domain goes from A to B. Now, in a discrete domain, and I'm on purpose not using numbers here. So this is A, this is B, this is C, this is D, this is E. We would say that the domain is equal to, now we have to list the set. The domain is A, B, C, D, and E. Okay, so you're going to talk about domain differently depending on is your graph continuous or is your graph discrete. Now, when we talk about range, we're giving a vertical description. How high does our graph go? Now notice when we're talking about the domain, we talk about how far left to how far right. So when we talk about the range, we're going to talk about how low it goes to how high it goes. Okay, so I'm just going to say that this height right here is the letter C, this height right here is the letter D. So the shading is between C and D, and it starts at C and it goes to D. So we would say that the range of this graph goes from a height of C, and I have to use Y because I'm talking about my vertical description. It goes from a height of C to a height of D. So again, when we're talking about domain and range of continuous graphs, we have to write an inequality. Now, when we're talking about discrete domains and range, we have to talk about the individual value. So this value could be F, this value could be G, E, F, G, H, I go to my alphabet, I, E, F, G, H, I, J. Right, so the range of this would be, I believe it's all right, the range would be F, G, H, I, and J. All right, so again, the way we write domain and range is dependent on is our graph continuous? If it's continuous, you have to use an inequality. If it's discrete, you have to list the elements of the X values for the domain, the Y values for the range, horizontal description, vertical description. So that's basically it. This is, by the way, this would be considered a continuous graph. Okay, so hopefully this is enough information to answer the questions in 3.1. Have a good day, everybody. I'll see you later. Bye-bye.